This one is a geometry question. Concept tested primarily is circles and properties of tangents of circles. Appeared as a 2-mark question in 2016 CBSE Class 10 board exam. Let's start by reading the question. A quadrilateral ABCD is drawn to circumscribe a circle with center O. Circle with center O, it is circumscribed by this quadrilateral ABCD in such a way that the sides AB, BC, CD and DA touch the circle at points P, Q, R and S. What we need to prove is AB plus CD, the sum of one pair of opposite sides, is equal to BC plus DA, the sum of the other pair of opposite sides. Let's start by doing this. This is the diagram that we have. The first and foremost thing that you need to keep in mind is when a quadrilateral circumscribes a circle, the four sides of the quadrilateral will be tangents to the circle. Solving this question is entirely hinges on this one property that I'm going to state. From an external point, we'll be able to draw two tangents to a circle. Both these tangents will be equal in length. Solving this question depends on only this property. Let's set about doing this. From external point A, we'll be able to draw two tangents AP and AS. AP is a tangent, AS is a tangent to this circle from point A. Both these will measure the same. Let's assign a value to it. Let's say both these measure A units. So AP equals AS is equal to A units. We're going to be repeating the same thing for all four vertices of this quadrilateral. From point B, we'll be able to draw two tangents BP, BQ. Both will measure the same. Let's assign a variable. Let's say let them measure B units each. Similarly, from point C, we'll be able to draw two tangents CR and CQ. Both will measure the same, which is going to be equal to C units. And lastly, from point D, we'll be able to draw two tangents DR and DS. Let both these tangents measure D units each. So we've assigned variables, we have identified equal tangents. Let's find out what do we have to prove. Our objective is to prove that AB plus CD is equal to BC plus DA. Let's start with LHS. The LHS is AB plus CD. What is AB? AB can be broken down as AP plus PB. That's what I'm going to do. AB can be written as AP plus PB. We have done that. What is CD? CD can be broken down as CR plus RD. Now, what is AP? We have assigned a variable for AP as A. So, AP is equal to A, PB is equal to B, CR is equal to C, and RD is equal to D. Sorry, LHS works out to A plus B plus C plus D. Let's call this as equation 1. Let's leave it here as it is. Let's move on to the RHS. What is RHS? RHS is equal to BC plus DA. Let's do the same thing. BC can be broken down as BQ plus QC. BC is BQ plus QC. Similarly, what is DA? DA is equal to DS plus SA. So we'll write it as DS plus SA. BQ is nothing but B. QC is nothing but C. So let's replace that. This is B plus C. DS is nothing but D and SA is equal to A. So this is B plus C plus A plus D. So RHS works out to this. We'll call it as equation 2. Take a look at both these equations. Equation 1 is A plus B plus C plus D. Equation 2 is B plus C plus A plus D. By commutative property of addition, A plus B plus C plus D should be equal to B plus C plus A plus D, which means LHS is equal to RHS. We have proved what we have to prove. Quickly sum it up in a printed form. LHS is equal to AP plus PB plus CR plus RD. That works out to A plus B plus C plus D. RHS is equal to BQ plus QC, which is our BC, and DS plus SA, which is nothing but DA. BQ is a B, QC is a C, DS is equal to D, and SA is equal to A. So equation 2 is B plus C plus D plus A. Commutative property of addition makes LHS to be equal to RHS. Quickly recap the properties associated with this. These are the two properties you need to remember. First one, from an external point, we can draw two tangents to a circle. Both these tangents will be equal in length. This entire question, solving this, dependent on this. Having solved this, we'll derive a new property about quadrilaterals in circles. If a quadrilateral circumscribes a circle, or if a circle is inscribed in a quadrilateral, some of the opposite sides of the quadrilateral will be equal. Essentially what we are saying is AB plus CD will be equal to BC plus DA.